and they ask us what are the coordinates of the vertex of this parabola. What form is this equation in? Yeah, vertex form, so it's really easy to tell what the vertex is, right? What is my vertex? By looking, just like looking at the template. Yeah, the H and the K. And H is the opposite sign of what you see. K is the same side as what you see. So what is my H going to be? Opposite sign of what you see, so -2. And what's K? Good, -3. We had a problem like that on one of your quizzes recently, and I saw a bunch of people just either flip-flopping the numbers or forgetting that it's the opposite sign for H. So remember, H, opposite sign, and the K is the same sign. And then what about the line of symmetry? What would be my line of symmetry? X equals, yeah. So from vertex form, right, HK is my vertex. My axis of symmetry is just X equals H. So we already figured out H is -2. So my axis of symmetry is just X equals -2. Right, and that makes sense if I think about my parabola. My axis of symmetry is that vertical line going through the vertex. Okay, so it has to be that. All right. Now we need to graph this. So I know my vertex is at -2, -3, -2, -3. So that's where I can start. But what do I do from here? How can I figure out the rest? Can I see my x-intercepts from this form? No. Can I see my y-intercept from this form? No. We need to convert it to a different form to get those two pieces of information. So let's convert this to general form. So we're going from vertex form to general form. What do I do first to convert this to general form? Yeah, we got to FOIL this part right here. So this becomes 3 times x plus 2 times x plus 2, right? X plus 2 squared is just x plus 2 times x plus 2, and then minus 3. Okay, so now we FOIL. First times first is what? X squared. What's my outer times outer? My inner times inner. And my last times last? 4. Now, this 3 is multiplying this. So that's my next step, is I need to distribute this 3 to everything inside. But let's like clean this up a little bit because I have these two like terms here. So it really is 3 times x squared plus 4x plus 4, and then minus 3. Now I'm going to distribute. So I have 3 times x squared is what? 3x squared, and then 3 times 4x, 12x, and then 3 times 4, 12. And then I have this minus 3 at the end. So I have 3x squared plus, oops, I forgot my x, plus 12x. And then I can combine my like terms there. What's 12 minus 3? 9. So plus 9. Now do I know something from general form? What do I know from general form? Can you guys see with that thing there? What do I know from general form? Not your x-intercepts. The y-intercept. What is the y-intercept? Good. 0c. This c tells me my y-intercept. So what's c in this equation? 9. That's not right. That's not quite right. Because that's way up here. Maybe that's right. That could be right. That can be right. Okay. Now, I also want to figure out I figured out my y-intercept and my vertex. What else should I figure out? X-intercept. What form should I be in to figure out my x-intercept? Intercept form. That means I need to factor this. Factor this. Do you see a greatest common factor in here? Yeah, 3. So I'm going to take my 3 back out. Take the 3 back out. And I have x squared left over. And then what's 12x divided by 3? Good, 4x. And then 9 divided by 3? 3. Okay. Now I'm going to factor this. I can leave that 3 alone out in front. What times what is going to give me this x squared? Yeah, x and x. And then what two numbers multiply together to get to 3? 1 and 3. And can I use 1 and 3 to get to 4? Yeah, just a positive 1 and a positive 3, right? So then that tells me where my x-intercepts are. Where are my x-intercepts? Huh? -1 and -3 are my x-intercepts. So -1 and -3. So I have like a really skinny parabola. It's kind of hard. Okay, but I know my vertex, I know my x-intercepts, and I know that y-intercept. And then that y-intercept also lets me draw this point right here too, right? Because I know that my parabola is symmetrical. Okay. I know that's a lot of work, but did it make sense what we did? Okay. Right, we went from vertex form to general form, and then general form to intercept form. And that let us figure out like all the parts of the parabola: vertex, y-intercept, x-intercept, x-intercept. And then I'm able to draw it from there. Okay. All right, and number 2. I've got my table. We want to write an equation of the function in intercept form. So intercept form, right, has my x-intercept, y equals a times x minus p times x minus q, where p and q are my x-intercepts. Can we tell what my x-intercepts are by looking at that table? How? Yeah, it's where y equals 0. So where is y 0? And 4. Perfect. Okay, so then what would that part of my equation be? It's going to be like x and x. Opposite sign. Yeah, so plus 2 minus 4. And do you remember how we figure out what a is? How do we figure out a? Anybody? We have a whole bunch of values right here, right? They're all x and y. I have a whole bunch of x and y values. That means I can take one of those pairs and plug the x coordinate in for x and then the y coordinate in for y. And that'll let me solve for a. So looking at those different values, I can see this one's going to be probably the easiest because there's a 0 there. And 0 is really easy to like do any math with, right? So I'm going to plug in my 0 for x and my -4 for y. And that's going to let me solve for a. Okay, so I plugged in -4 for y and I plugged in 0 for x. Okay, so what's 0 plus 2? Bless you. 0 plus 2? 2. And 0 minus 4? -4. So I have a times 2 times -4 equals -4. And then I'm going to multiply those. 2 times -4 is? So -8a equals -4. How do I solve for a now? Divide by what? Yeah, the -8. So what's -4 divided by -8? Yeah, 1/2. So that tells me that a equals 0.5 or 1/2, whichever way you want to write it. And now I can finish writing my equation because I can replace a with 1/2. So my equation is y equals 1/2 times x plus 2, x minus 4. Okay. On your quiz the other day, if you got this part right, I gave you half credit. Like that's halfway there. And I only took off half a point for getting A. So, or for not putting an A. If you tried to put an A and you got it wrong, I gave you a quarter of a point more. So this is kind of the most part of what I'm looking for, but if you can get to that value for A, that's like full credit. Does that make sense? Okay. Okay, now I got to write it in general form. So what do I do? How do I go from intercept form to general form? FOIL. So I'm going to do first times first. What's first times first going to give me? X squared. What about my outers? X times -4. Yeah, -4x. And what's my inners? 2x. And what's my last times last? -8. Okay, and then I can clean it up. I can simplify. What's -4x plus 2x? Yeah, -2x. So I've got x squared minus 2x minus 8. But then I have this 1/2 out front, so I need to distribute that now. So what's 1/2 times x squared? You guys written anything down? You can use this on your test, but if there's nothing there, it's not going to help you very much.
All JV and varsity basketball girls. JV and varsity basketball.
Dory, there's going to be a video of this on Google Classroom if you want to finish getting the notes down later. What's 1/2 times x squared going to be? 1/2 x squared. What's 1/2 times -2? Yeah, so -x and 1/2 times -8. There you go. There's the general form. Okay. All right, now we're just kind of like factoring and foiling. That's all we're doing. So this is 5x plus 6 squared, right? That's 5x plus 6 times 5x plus 6. Let's FOIL it. What's first times first going to be? Yeah, 25x squared. 25x squared. And what's my outers going to be? 30x, and then my inners. So what's 30x and 30x? 60x. So that's my middle term. And then my last times last is 36. Perfect. Okay. In part B, you had one like this on your quiz as well. So start by looking at this blank right here, because I need my last times my last to give me the 12. So what times 4 gives me 12? 3. So the 3 goes there. And then I can figure out my middle term because it's just my outers and my inners. So what are my outers? X times 4. 4x. And my inners? 3x. What's 4x plus 3x? 7x. Good. Okay, and same deal here, except kind of the opposite, right? I'm going to look at this one first because I know my first times first has to give me this 6x squared. So what times 1 is going to give me 6? 6. Okay, 6. Wow, that got really messy. 6. Okay, now that I know that one, I can look at my outers and my inners, and I know that they need to get to -5. So if my outers are going to be -6x, so -6x plus what would give me -5x? -6 plus what gives you -5? 1. So that's got to be a 1. So now I just have my last times last. 1 times -1 is going to give me what? 1 times -1? -1. So that 1 goes there. Okay? Good? Questions? All right. Number 4. All right. What do I do to solve something like this? What should I check for first? Yeah, let's see if we can factor this. So I look at my last number. My only option is 7 times 1. Can I use 7 and 1 to get to -4? So that's not factorable. So what should I use instead? Yeah, the quadratic formula. Write that down. X equals -b plus or minus the square root of and let's again figure out our let's identify A, B, and C first. So what's A? B and C? Good. Okay, let's do our discriminant then, the b squared minus 4ac. So what's b? -4. I'm going to do -4 squared minus 4 times 1 times -7. What's -4 squared? Good, 16. So minus 4 times 1 is 4. What's 4 times -7? Yeah, -28. So I have minus -28. What happens when I subtract a negative? positive. So 16 plus 28, good, 44. So now I have 44 underneath the square root sign. Is 44 a perfect square? No, so we're just going to leave it there like that. So let's finish filling this all out. So I've got x equals negative b. So that's negative, oops, 44. X equals negative 4 plus or minus the square root of 44 divided by 2 times 1. Negative 4, what happens? Yeah, it's a positive 4. So now I have 4 plus or minus 44 divided by 2. You can leave your answer like that. I'm not going to be super picky about it, but you could also like figure out the approximate value of both of those solutions, right? Do you want me to show you that on the calculator? Yeah. Okay. This answer is good enough just as that is. There's ways of like simplifying the radical, but I'm not going to get into that with you guys. But we can also just figure out the like approximate value. So if I take, what was it, 4? Yeah, 4, let me clear everything out so I'm not confused. 4 plus the square root of 44. And then I'm going to just hit enter so I don't have to deal with parentheses. But then I'm going to divide it by 2, right? Divide by 2. So 5.32. So that's one answer is approximately 5.32. And then my second answer, I do the same thing except for minus square root 44 divide by 2, negative 1.32. And those are my two answers. Those are my two answers. But again, this answer is just fine. I'd give you full credit for that. Okay. And since my discriminant was a positive number, I know that I should have two answers like that, right? All right, now I got to solve part B. What can I do for B? You could FOIL. We could FOIL and put it in general form and then use a quadratic formula again. We can also do something a little easier. Because isn't this a thing times another thing that's equal to 0? That tells me that this could be 0 or this could be 0. If x plus 3 is 0, what is x? Yeah, negative 3. And then here, how would I solve for x? Not yet. Not yet. What do you do first? Yeah. Add the 1 first. So then 2x equals 1, and then we divide by 2. So x is 1/2. Okay, because that was from factored form. So I can just set my two factors equal to 0, and that solves the equation for you. And then what about part C? What do you want to try? What can we do for part C? Yeah, we could just do that. What's my A? And B? C? Good. Okay, let's do b squared minus 4ac first. So b squared is 1 squared minus 4 times 2 times 5. What's 1 squared? And then 4 times 2? And 8 times 5? What's 1 minus 40? Since my discriminant is negative, what does that tell me? 2 imaginary solutions. So we're going to have kind of a weird answer like this one again. Okay, so let's stick our negative 39 under the square root. I'll rewrite it. X equals negative b. Add or subtract square root b squared minus 4ac divided by 2a. So x equals negative 1 plus or minus the square root of negative 39 divided by 2 times 2. What's 2 times 2? 4. And that's all you need to do because we have that negative under the square root. So even if you plug it into your calculator, you're just going to get an error. So we don't need an approximate value when we have a negative discriminant. We can just leave it just like this, and that's perfect. Okay? Questions about those? All right. Okay, I've got this equation here, y equals x squared minus 2x plus 5. And they want me to find the solutions to 0, right? They're plugging in 0 for x, bless you. Or 0 for y, I'm sorry. So what can I do to solve this? Always try factoring first. So look at that. Look at the last number. What are the factors of 5? 1 and 5. Can I use 1 and 5 to get to negative 2? No. So that means I have to use that quadratic formula. So what's A? 1, B, C, 5. Okay, again, x equals negative b. Add or subtract square root b squared minus 4ac divided by 2a. Let's do our discriminant first. So b squared minus 4ac. B is negative 2, so b squared is negative 2 squared minus 4 times 1 times 5. Negative 2 squared is 4 minus 4 times 1 and 4 times 5, 24 minus 20 is what? Very good, negative 16. What does it mean if I have a negative discriminant? So are there any real solutions? Only 2 imaginary solutions. Okay. You don't need to worry about this. This is something called completing the square, and I didn't teach you how to do that, and it won't be on your test. So we don't need to worry about that. Okay, let's look at the other side then, right? That's it. Okay. All right, I've got a graph of a quadratic, and they ask me how many real solutions are there to this equation? How many real solutions are there? 2? Yeah, 1. Right here. 1 real solution. Right? It doesn't cross the x-axis twice. It's only touching it once. So there's only 1 real solution. So what does that tell me about the discriminant? Yes, the discriminant is equal to 0. Right? Again, when b squared minus 4ac when it is positive, there's going to be 2 solutions, 2 real. When it is negative, there's only going to be 2 imaginary. And when it is 0, there's only one real solution. Right? Okay, number 7, we got to find the value of the discriminant. B squared minus 4AC. So what is A? B? And C? Good. So B squared would be negative 20 squared minus 4AC. So 4 times 4 times 25. What's negative 20 squared? Negative 20 squared. Good, 400 minus, what's 4 times 4? 16. And what's 16 times 25? Huh? Yeah, 400. So 400 minus 400 is? So what's the value of the discriminant? 0. I had a bunch of you guys like doing the whole quadratic formula when it asks just for the value of the discriminant. And I gave you points if you like ended up there, but just know that that's like too much work, right? You can just do this part, okay? Okay, so if the value of the discriminant is 0, how many solutions does it have? 1 real, right? How many? There's 1. What type? It's real. Okay. What else do we have on here? Last one. Is this the last one, number 8? Yeah. Okay. All right. So now we have a word problem. And again, I think I've explained this before, that parabolas are really useful because that motion shows up in our world all the time. Because think about like a golf ball. If you hit a golf ball, it's going to go up and then it's going to go back down. And we can model that movement using a quadratic. And that's what rocket scientists do. That's what physicists do. Anyone that's studying this type of motion, it also comes up in like business a lot. They're using a quadratic to model that situation. Even in, Super Mario Brothers, if you like jump and you watch Mario, he jumps. He doesn't just jump straight up. He jumps and he keeps going because he has that forward motion. And if you look at the code of Mario, and we looked at this in computer science, my computer science class, when we wanted to make something look like it was going up and then down, like in real life, we used a quadratic in the code, in like the actual, like programming of the game. So this shows up all the time if you go on to study physics. Definitely if you go on to study any more math classes. Okay, so I've got this golf ball, and at 0 seconds, it's at 0 feet. And then after half a second, it's going up to 4.8 feet. And then after 1 second, it's up to 7.2 feet. And then after 1.5 seconds, it's back to 7.2 feet. And after 2 seconds, it's at 4.8 feet, right? So that's at 2. This was at 1.5. This was at 1. And this was at 1/2 second. So I want to figure out, and this is my equation that's modeling the same thing. I want to figure out what is the maximum height. What is the maximum height? And when will, like, what is that maximum height? It doesn't ask me when. But I could figure out when because it has to be equally distant from this 1 second mark and the 1.5 second mark. So at what point in time is it going to get to the top? Yeah, 1.25. So then if x equals 1.25, I'm able to figure out what y is. I just got to plug in 1.25. So y equals 12x, so 12 times 1.25 minus 4.8 times 1.25 squared. So 12 times 1.25. Yeah, 15. And then minus. Let's figure out 1.25 squared. It's 1.25 times 1.25. 1.56. That's what you got, 1.5625. And then what's that times 4.8? Yeah, 7.5. Okay, so I've got 15 minus 7.5 is what? Is 7.5. So that would be the maximum height. That's that vertex is at 1.25, 7.5. 7.5. That's not a very good hit. I mean, I guess maybe they're just like chipping it in, you know, but usually you want the ball to go way higher than that, don't you? Okay, so the maximum height is going to be 7.5 feet. And at what time is the ball going to hit the ground? So at what time is it going to be 0? That's going to be its x-intercept. Its x-intercept. So I know one of them is going to be at 0, but I got to figure out what this is going to be. So let's take our equation. Y equals 12x minus 4.8x squared. And I'm going to factor this, but I'm not going to factor it like this way. I'm going to GCF factor this. So I can see that I can take negative 4.8 out of here. This is kind of a mean problem. I'm going to take negative 4.8x out. That's going to be my GCF. So what's 12 divided by negative 4.8? What's 12 divided by negative 4.8? Yeah, negative 2.5. And then negative 4.8 divided by negative 4.8 is just 1. So I just have this plus 1x left over. Okay, and again, I want this to equal 0. I want the height to be 0 when it hits the ground. So that means that if this times this equals 0, then that means that this part equals 0 and this part equals 0. You can solve for 0 in this one by just dividing both sides. So x is 0. That's this point right here. When the time was 0 before he hit the ball was at 0 feet. But then also here, if I add 2.5, add 2.5, I find out that x equals 2.5, and that's this point right here. So after 2.5 seconds, the ball has dropped back down to the ground. There is like a word problem like this on your test, but I'll help you guys out on it because we didn't do a whole lot of practice with that. Okay. Do you want to look at it for 5 minutes, or do you want to just stop? Yeah, I'll just give your quizzes back, okay? But hold on to your quizzes because you can use them on your test tomorrow, okay? You can use the quizzes and the practice test.